Hey guys, welcome to section 10.3 in Math 112, hyperbolas. So we've talked about parabolas and ellipses, and a hyperbola is, in a way, kind of dual parabolas. And so we'll just let's give a nice definition. So very simply, a hyperbola is the set of all points in the plane, the difference of whose distances from 2 points is constant. So just writing that out is very weird, and you're like, how in the world, what am I, But let's get these two first simple examples where they're centered at the origin. We'll get those drawn out, and then from there we can kind of look back at this example. And so a horizontal transverse axis and a vertical transverse axis. So those are the two terms basically talking about which direction our hyperbolas open. So a horizontal transverse axis. So the transverse axis is kind of the axis that goes through them both. If it's horizontal, obviously it's going to be going left to right instead of up and down like vertical. And this means that our essentially two sides of our hyperbola are going to be facing in opposite directions, both opening to the sides, if you will. So very simply, let's get a nice little drawing here. So try and make these semi-equivalent. So, sorry about that. So this is the point negative A, negative C, A, C. Let's get negative B and B. And so what we have here is we have hyperbolas kind of going like this. And kind of like this. Okay, so these points here at C comma 0 and negative C comma 0, those are our focus. Okay, or foci, if you talk about them together. Okay, and those are the points in which the distances are fixed. So if we pick any 2 points, their distance, the difference of the distances from these 2 points is fixed. So it doesn't matter which 2 points, any 2 points on here, and we get that. Now there's a couple other things here that are going on that are really important. And so I'm going to try and draw these all in here. So imagine, if you will, if I was a perfect artist, these would be nice straight lines, kind of like that one. That was pretty good. And these are our asymptotes. And so just like a vertical or horizontal asymptote in rational functions from 111, these are lines that our graph will never touch. Our parabola or hyperbola will never touch. They will get closer and closer to these, but will never touch. And so then we can also create this rectangle, which again, I am not the perfect artist, so it is what it is. And this rectangle here, this is not something we always draw. I'm drawing it in here just to kind of show it, is something that we call the fundamental rectangle. Okay. What's really cool here is notice that kind of these corners of the rectangle, again, I'm a not good artist, so I apologize. Let me make this side a little bit better. This is just also with me not being to scale. Okay, so the corners of these kind of all fall on this, or they should. And so you can see that they fall at the A values and the B values. Okay, and so that's going to be important when we are kind of identifying how to draw these parabolas, as well as how to identify their equations based on their drawings. And so before I move on to our vertical, let's go through and get the equations for these. So the equations for this, again, because it's centered at the origin, is just going to be x squared over a squared minus y squared over b squared equals 1. Okay, and you may notice here that there is some similarities, if you will, with ellipses. The equation of an ellipses was x squared over a squared plus y squared over b squared equals 1. Notice that this is subtraction. So if you have addition, it becomes an ellipse. You have subtraction, it becomes a hyperbola. So that's very different, right? So I'm sure in this class and in other classes, you've had teachers and people talk about, being careful with your signs, make sure you carry those through correctly. This is a big reason why. So make sure that you guys are being very careful with that. And yeah. So if this is our equation, it's centered at, very simply, 0, 0, the origin. These are nice ones. We have the vertex, because like I said, you can kind of see this as a parabola on the left and the right. So we have two vertices, one at a comma 0 and one at negative a comma 0. So we'll just say plus or minus a comma 0. Our foci, those points that similar to parabolas and ellipses, right? We have these foci and they are kind of work similarly. That's plus or minus c. We'll talk about how to get those equations, comma 0. And then our asymptotes, these lines that we drew in here, right? So those are going to be lines. So their equations are going to be y equals plus and minus b over a times x. So that means to get these equations of these asymptotes, we simply take our b value divided by our a value and multiply by x. Now that is because this is a horizontal transverse. We're going to move over here and do the vertical transverse here, and you'll see the differences. So again, we have C, A, negative C, and negative B here and B here. And I'll try and draw this out without it getting too terrible. This time I'm not going to draw in the fundamental rectangle because we don't exactly need it, and I don't want to. So we get all of these same features here, right? Again, if you kind of look up here, right, where we intersect with this B, if we draw a line straight up through that intersects with our asymptote kind of at a horizontal with A, and so we get that kind of similar relationship. I'm just going to go ahead and do it because I'm a sucker and I can't not do it. So, all right, there we go. That was a little better than last time. Again, our equation is very simple. We have y squared over a squared minus x squared over b squared equals 1, centered at 0, 0. This again is one that's centered at the origin. Our vertex are 0, comma, plus minus a. Our foci are 0, comma, plus minus c. And our asymptotes here have the equation of y equals plus or minus a over b times x. Now, you may be going like, this is confusing. Things are flipping. Like in a horizontal, we have a is with x and b is with y, but in a vertical, a is with y and b is with x and all of these things, right? The easiest way to think about it is the a is with the positive, the b is with the term that's being subtracted, so that kind of negative. So the b is with the negative, the a is with the not negative. So that's a nice way that I like to think about this. It helps me to more easily see that. So make sure you guys keep that in mind. Oops. There you go. So how do we find the foci? How do we find this lovely magical C here that we're talking about? Well, it's really easy. It's a very common formula, very simple formula. It's c squared is equal to a squared plus b squared. So nothing too crazy. That looks like a 4 now. Okay. So take an a value, take a b value, square them, add them, square root them, and you get c. So good old Pythagorean theorem. Now, when we're looking at these equations, remember, it's very important to remember that our a values and our b values are squared. So if our equation were to be something like, say, x squared over 4 minus y squared over 9 equals 1, our a would not be 4, but it'd be 2, because 2 squared is 4, and our b value would be 3. Okay? Now, if these equations were like written with a square in there, then that changes things, and those become our exact a value and b values. But as is, just do it like that. So that is our very simple example with it being centered at the origin. Now, of course, not everything is nice and simple. So what if it's not centered at the origin? So this is a more general form. And yeah, it's just very nice. So before, look up here, so our horizontal transverse axis, in this case, is the x-axis. And our vertical transverse axis is the y-axis. However, if they're not centered at the origin, our transverse axes may be other places. So in our example here, for our horizontal transverse axis, we're going to have it be right here. So this point here is going to be h minus c comma k. Point right here. This point right here is going to be h comma k. Point right here, and I'm running out of room. H plus c comma k. All right. Now this point here is going to be h minus a comma k. This point here is going to be h plus a comma k. And now we will get our parabolas coming off of there. These are not drawn the best, but they are drawn the best I can do. Now you may be wondering, well, where's my b? Right? We don't always know exactly what that is, but I mean, if you wanted to have that point here, right? That point would be very simply at h comma k plus b, and then if we did one down here, it would be at h comma k minus b. We aren't going to label those. I've noticed it's not even in one of our things that we're identifying here. There's no b's in here except for in the asymptote. That's really where it's used at. So our equation for this becomes simply shifted by h units, and then shifted by k units. So really similar to the things we've already done that we've seen like this. We've seen these kind of generic terms and then shifting things around. And so hopefully this isn't something that you're going like, oh my gosh, this is blowing my mind. The only way it should blow your mind is if you're just finally now understanding exactly how it works. So if we have something like this, it is going to be centered at the point h comma k. Notice that in the equation, it was x minus h and y minus k. But then it's centered at those h and k values, so we need to be careful with the signs. The vertex will be at h plus or minus a comma k. And then the foci will be at h plus or minus c comma k. And our asymptotes will be at y equals plus or minus b over a times x minus h plus k. So we get a much more complicated asymptote here. And the reason why it's complicated is because it's been shifted. And so we look at this, we're like, man, there's a whole lot going on. I've got fractions, multiples, parentheses, subtraction, addition, positive, negative things. I have all this stuff going on. But if we really break this down to the difference, right? If it's centered at the origin, it'd be at b over a times x. Now, if I take this exact line and I shift it to the right h units, well, that's just b over a times x minus h. And then if I shift it k units up, well, that's just plus k. And so while it may seem like it's a lot more complicated, it's really just two basic transformations shifting left and right or shifting up and down. So really nothing that we need to get too fussy or concerned with. Really simple. Now, if we have a vertical transverse axis, that means our axis is going vertical. We have our lovely c value of h comma k plus c. We have our a value, that is h comma k plus a. We have our other a value, which is h comma k minus a. We have our foci, which is going to be at the point h comma k minus c. This is all centered at hk. We have our hyperbolas going like this with our asymptotes passing through the center. I notice I didn't draw our asymptotes in here. So our asymptotes go through the center. So the intersection of our asymptotes are the center. So if you were to be given two asymptotes, saying these are the asymptotes of a hyperbola, you could calculate the center by simply finding the point of intersection. And that would give you your h and k values. And from there, you can figure everything else out. So let's look at the equations and all those other good points. So because this is a vertical transverse, remember the vertical axis is y. Y is going to go first. So we get y minus k squared over a squared minus x minus h squared over b squared equals 1. Notice here I'm not shifting the h and k because if we go all the way back to Math 111 when we talked about transformations and we did shifts, translations, if you will, h was always associated with our horizontal transformation, our horizontal shifting, with our x value, with our input value, and our k associated with our y values. So we want to keep that the same, and everything else is the same here. So again, this is still centered at h comma k. Our vertex, however, instead of being h plus or minus a, it's going to be h comma k plus or minus a. Our foci similarly are going to be k plus or minus c. And our asymptotes are going to be y equals plus or minus a over b times x minus h plus k. Again, it's really the exact same thing we had before with a horizontal and vertical shift. That's it. Okay. So when we're creating our asymptotes, it is simply the value under the y term is the numerator. So if it's a horizontal transverse axis, the b is over the a. If it's a vertical transverse axis, it's the a over the b. And again, our foci, our c value is exactly the same. C equals a squared plus b squared. So nothing too crazy. So now we've talked about these. We've talked about how we can identify these points based on the equation itself or the graph, kind of being able to look at those. So let's do some stuff. So I want to find the center, vertices, foci, and asymptotes of this equation, and then I want to give a rough sketch of this. So first thing I notice when I'm looking at this is going to be centered at 0, 0. And the reason I know that is because the x and y terms are just by themselves, y squared, x squared, really easy. Okay, so center is going to be 0, 0. Now the next thing I notice is I have the y term minus the x term. So if we go back up here, I want to go to our general equation, even though I could go up to the first one. If I have the y term being subtract from if I have the x term subtracted from the y term, so the y term's first, that is a vertical transverse axis. So if we come down here, I just want to make a note to myself that this is a vertical transverse axis. So our vertices of this are going to be, our vertices are very simply going to be, well, so we can go up here because it's even easier, 0, comma, plus or minus a. So my a value comes from here, and we get that a is equal to 2, and b equals 3. So our vertices are going to be at 0 plus or minus 2. That's pretty easy. Okay. Now our foci require a little bit of work because remember, those are going to be 0, comma, plus or minus c. So let's solve for c. We know that c squared is equal to a squared plus b squared. I don't like where I'm doing this. Do it over here. C squared equals a squared plus b squared. So that means I have 2 squared plus 3 squared, which 2 squared is 4, 2 squared is 9. Add those together, we get 13. Okay, so that means that c squared equals 13. Square root both sides, we get c is the square root of 13. Now we don't need to worry about the plus or minus because, well, basically the problem involves both. So it really kind of doesn't matter. So our foci are going to be the points 0, comma, plus or minus square root of 13. And for those of you who are just really needing to know what the square root of 13 is as a decimal approximation, it's about 3.6. So that'll give you kind of that idea. Now, we have our center, we have our vertices, we have our foci, we need the asymptotes. So to find our asymptotes, it's y equals the value that goes with y, so in this case that's a, over the value that's associated with the x, which in this case is b. So it's going to be plus or minus 2/3 x. There's no h, so I don't need to worry about that. There's no k, so don't need to worry about that. It's just simply plus or minus 2/3 x. So let's get our graph. Now, since we're a vertical transverse axis and we're centered at 0, 0, I don't have to do any sort of axes on here. It's just going to be the y-axis. And so our first thing we're going to do, let's get back in here, okay, is label our points. So this is the point here. This is 0, 2, 0, square root of 13, 0, negative 2, and 0, negative root 13. And obviously our origin 0, 0. So here's our rough sketch. I'm going to get my asymptotes in here. I'm going to make this look a little less like it's coming back in on itself. And there we have it. We have a rough sketch. If you want to, you can also include the equation of these lines. So like this is the line y equals negative 2/3 x. This is the line y equals 2/3 x. Remembering that these are just lines. So the negative version is the negative slope, the decreasing slope. So easy enough. Let's do another one. Let's do a more challenging one. So this one here, we need to again find the center, vertices, foci, and asymptotes. We have our equation. Then we want to get a rough sketch of the graph. We're doing the exact same thing. The difference here is, just looking at this right away, I see that my center is not going to be at 0, 0. I see I have the x term first. We're subtracting the y term. So that means that this is going to be a horizontal transverse axis. Okay, So I have my center, my vertices, my foci, and then our asymptotes, but I'm going to leave that because I want to get some room. So our center, HK, remember, H is the term that goes with the X, K is the term that goes with the Y. They're defined to be X minus H. So since these are X minus 3, Y minus 1, our H and Ks are both positive. So H is 3, K is 1. So it's centered at 3, 1. Our vertices. So before we do anything else, A is the square root of 36, which is 6, and B is square root of 4, which is 2. So our vertices are very easy. If we go back up here, we have a horizontal transverse situation. It's not centered at 0, 0, so we need to use this formula here for our vertex. And so we have H plus or minus A, comma K. So our H value is 3. Our A value is 6. So our vertices are going to be 3 plus 6, comma 1, which is 9, comma 1. And our other vertices, our other vertex, is going to be 3 minus 6, comma 1, which is going to give me negative 3, comma 1. So those are my two vertex. Now, to find my foci, I need to find C. So C squared equals 6 squared plus 2 squared. Now, what's nice about this, the way these equations are written already, is the A and B is already squared in the equation. It's 36 and 4. So if I just add this together, I get 40. So C squared equals 40, square root both sides. And C is a lovely square root of 40. Or if you want to, you can say 2 root 10. I'm going to go with square root of 40 because that's what I want to do. So now our foci, which if we go back up here, our foci are at H plus or minus C, comma K. So basically the same exact thing that we did for our vertex or our vertices, except instead of plus or minus A, plus or minus C. Now, because we don't have a nice number here, because we have square root of 40, I'm not going to do them individually like I did for the two vertices to get these exact points. I'm just simply going to write them as 3 plus or minus the square root of 40, comma 1. And that's it for the foci. That's all we have to do. The last thing to do is get our asymptotes. Our asymptotes are going to be y equals plus or minus, and then I need to take the, just a sec, sorry guys, my son is getting in here. Take it to mommy. I'm going to take our y term. So in this case here, our y term is the b value, which in this case is 2. Divide by the a value, which is 6. And then it needs to be multiplied by x minus h, so minus 3, plus k. And so we get this. Plus or minus 2 over 6 times x minus 3 plus 1. If you want to simplify that 2 over 6 to 1/3, that's perfectly fine. It's equivalent. It's the same. You could absolutely write plus or minus 1/3 x minus 3 plus 1. I really don't need you to distribute this whole thing out. You absolutely could if you wanted to. And you could write this as, let's see here, it's plus. So I'm not going to do it. Because the reason I'm not going to do it is you have to create 2. Because 1, we get 1/3 x minus 1 plus 1. So we get 1/3 x. The other one, we get negative 1/3 x plus 1 plus 1. So we get negative 1/3 x plus 2. So we get 2 different equations. I'm just going to leave it like this because it's simple, easy, and we don't really need to get that complicated. Now, let's get our graph. Our center here is 3, 1. So 1, 2, 3, 4, 5, 6, 8. Okay. So our center is at 3, 1. It's a horizontal transverse, so we are going to try and make a nice, that was abysmal. Okay, that's going to be good enough. Now our vertices are at 9, 1, so I didn't even go out far enough. So it's 8, 9, 10. So our vertice, here's one, is at 9, 1. And our other one is at -3, 1. And then from there, our foci, now if you want to, again, get that approximation for the square root of 40, we get 6.32. So I'm going to have one foci is at 3 plus that, which gives me a little over 9. The other one gives me a little below 9. Okay. And so we're just kind of going like this. I'm not getting too crazy with it. Again, if you want to draw in your asymptotes, go for it. I am going to, because I am a mathematical professional. Just kidding. And that's it. That's really all we need to label. We don't need to get crazy with these things. I already have all the points labeled right next to it. I don't need to label them on the graph as well. If I did nothing on the left-hand side here, if I had none of that written down, I just had this graph, it would be very important for me to label all of these points. It'd be very important for me to, especially our foci, it'd be very important so that as the person grading this, I know what you're thinking there. Yeah, so not bad. Now, what if you get a problem that's not written in this standard form, this x minus h squared over a squared minus y minus k squared over b squared equals 1. What if you're given something that looks like this? Well, you have to do a couple things. One of the things we have to do is complete the square. Now, I know if you had Math 111 with me, we did not do completing the square. And I believe at Chemeketa Math 111 does not really do completing the square. Look it up if you really want to. I'm not too stressed about it, especially right now. You guys are home, so feel free to use Google, help you do completing the square. Wolfram Alpha is a great resource. You could do something and say complete the square, give it the first 2 terms, and it'll do it for you. So what completing the square simply does is it takes the x squared and x component and you tack on an extra constant, and that makes it a perfect square. And so to do this, we're going to have x squared minus 16x. I'm going to leave a blank space, minus y squared plus 16y equals 16. Now, I didn't leave a blank after the y because I need to do something else in between. So let's just focus on the x piece here. So I have x squared minus 16x. So what I need to do is I need to say what goes here, what constant value goes here, so that I could factor the x squared minus 16x and whatever this is, so that it's just an x plus or minus some number squared. And that's what I want to do. Now, since it's negative 16, I know that it's going to be an x minus something. So when I factor this, okay, it's going to be an x minus some number, and that whole quantity is going to be squared. And so I have to think what number, and so I don't want to go into this too in detail, but basically take this number, divide it by 2. So negative 16 divided by 2 is negative 8. So it's going to factor to be x minus 8 squared. And so to get that, I need to add 8 squared. Now you may be asking yourself, why are you adding 8 squared when it was negative 8? Shouldn't it be minus 8 squared? But if you think about when you're foiling x minus 8 squared, that constant term is going to be negative 8 times negative 8, which becomes positive. Now, I've changed this equation. I just added 8 squared. I added 64 onto the left-hand side. This is no longer a balanced equation. I need to balance it back out. To do that, I'm going to add 8 squared to the right-hand side. Okay? So what I did here, let me do this actually. So we have our original equation, x squared minus 16x, leave a space, minus y squared plus 16y equals 16. I'm going to add 8 squared to both sides. What that then does for me is it allows me to factor x squared minus 16x plus 8 squared to be x minus 8 squared. Okay. So what I've done so far is I've just added in this 8 squared to both sides. So everything's good. We add the same thing to both sides. We're okay. What that allowed me to do is it allowed me to factor x squared minus 16x plus 8 squared to be x minus 8 quantity squared. Now, before I dive in on this next part, I want to factor out a negative. So I'm going to read, this is negative y squared minus 16y, leave a little gap, equals 16 plus 8 squared. Okay. So again, in here, I need to figure out what to add in. I'm going to do this one in red. Figure out what needs to go in here. So that is a perfect square. So just simply divide negative 16 by 2. We get negative 8. So that just becomes plus 8. 8. Wow, why can I not draw an 8 right now? 8 squared. Now, that gives me what I want in terms of the next row. The next row is going to be x minus 8 squared minus y minus 8 squared. However, because of this right here, let's go galaxy on this. Because of this right here, that makes this plus 8 squared inside here actually a minus 8 squared. So on this left-hand side, I subtracted 8 squared. So I need to also then subtract 8 squared on this right-hand side to balance this out, right? And that is simply because if I distribute, we have a negative 8 squared. So that's where that's coming from. Now, what's cool about that is that means that these are gone. So after completing the square on both of these, I ended up with x minus 8 squared minus y minus 8 squared. And that equals 16. So you may be thinking, okay, but what I need my a and my b value, right? But if you remember, let's go back up to our equation. Both of these equal 1. Okay? It has to equal 1. This equals 16. So I simply need to divide by 16. Now, I'm writing it like this, and just remember that if I have something like a minus b over c, I can split this to be a over c minus b over c, right? Because if we do the subtraction, it's got a common denominator. The denominator becomes its own thing. We get a minus b. So that is the reason why I can divide each term individually by 16. And it's not breaking any rules. So what I end up with is I end up with the final equation of x minus 8 squared over 16 minus y minus 8 squared over 16 equals 1. And that is our equation. And so what's really cool is a equals b equals 4. H equals k equals 8. That is just in this equation, just because of the nice mirrored nature of this problem here. No other reason. Now, we need to figure out, is this a horizontal or vertical transverse? And it's simply based on which term is being subtracted. The y term is being subtracted. So this is going to be a horizontal transverse problem. So this is going to be horizontal transverse axis. Our center is h comma k. Both are 8. Our vertex, our vertices, I'm going to say vertex. I'm not going to say vertex. Our vertices. So since it's a horizontal transverse, so that means we're going left to right, it is going to be h plus or minus a comma k. So this is going to be 8 plus 4 comma 8, which gives me 12 comma 8. And it's going to be 8 minus 4 comma 8, which is going to give me 4 comma 8. So those are my two vertices. Now my foci, to find those out, c squared equals a squared plus b squared. C squared equals 32, or 4 squared is 16. 16 plus 16 is 32. And c is equal to the square root of 32. We're just going to leave it at that. 8 plus or minus the square root of 32, comma 8. Again, those of you who are curious about the square root of 32, 5.66 roughly. Now, what about our line, our asymptotes? Okay, those are both going to be y equals plus or minus. So if our a and our b value are the same, it doesn't really matter whether a over b or b over a, it's going to be 1. So we just get plus or minus x minus h plus k. And that's it. Now, you could absolutely get a rough sketch of this graph. I think at this point here, it should be kind of overkill. We're not being super exact with these graphs. We're being very sketch with these graphs. So keep that in mind. But there you go. There you have it. That is hyperbolas. It's really not too bad. Follow those formulas. Keep those things in your mind. And that's it, you guys. Awesome. Have fun as always. If you have any questions, email me.